Okay, last time we were talking about, I thought I had it up and running. There it is. We were in chapter 8. We were talking about strings. We looked at the example where I inputted a number, came in as a string, and then I checked to see if it's a decimal. And if it wasn't a decimal, not a decimal, then I asked for the input over and over until they got it right, and where they didn't put in a decimal. And then at that point, I changed it to an integer. Now, let's run this. And if I put in 3.12, now you notice it says not a number. So there's other options that you'll see. And that's where we left off. Let's see. Is alphanumeric, returns true if all characters in the string are alphanumeric. Is alpha, true if all characters in the string are in the alphabet. Is decimal, if strings are decimals. Is digit, returns true if all characters in the string are digits. So that comes back with that. Now if I put in 0.3 here, see how it comes back with false. So decimal is still not a digit. Now let's go to the alphanumeric. Now alphanumeric covers letters and numbers, but I don't know what it does with the decimal, to be honest. Guessing it will return false. It does. So if you're trying to achieve some kind of input, and you're trying to use these, then I'd recommend coming out here and playing with these and see. You can also do searches against your string to look for a specific character. See. Returns true if the string is an identifier. I have no clue what that one is. It's a valid identifier. It's invalid if it only contains alphanumeric letters, 0, 9, or underscores. Oh, that's a bizarre one. Kind of like where you got a valid variable name, sounds like. Is lower, returns true if all characters in the string are lowercase. Is numeric. Let's see. Let's see how that handles decimals. We might have looked at that one. It's still kind of early. I'll wake up here eventually. False. Okay. Yeah, I think we did try that one. Is printable. All the characters in the string are printable. So something's not printable. Okay, so that's well, I guess printed true, didn't it? Okay, let me change this. Okay, return false because this is a tab stop. if you print it, you can't see it. Now you're sitting there, may wonder, well, what's that look like? Print text. Putting a /T in there causes it to go over the next tab stop. Kind of like pressing a tab in Word. Is space returns true if all characters in a string are white spaces. Is title follows the rules of a title. Never, well, I've looked at it past semesters, but I don't remember it. I've never really used that in real anything meaningful. Returns true if all words in the text start with the uppercase letter and the rest of the words are lowercase letters, otherwise false. Okay, so this would be true since all these start with capital. Is upper returns true if all the characters string are uppercase. Join the elements of iterable to the end of a string. Saying that right? Okay, so we got our x equals, and then we got our pound sign, and join, and then my tuple. We haven't talked about my tuples yet, but it's a list, basically. You can think of it that way. And so this joins together the pound sign with those items in the list. You see it separated by that. Pound sign is probably not too useful, although there's other ways to do it. This is a very easy way to create a comma separated list. CSV. So that's a format that data is interchanged. So if you want to send something to Excel, putting a comma between them would cause you to be able to do that. Like I say, there's other ways to do that. LJust returns the left justified version of the string. So you see you got banana here, and then you got it's left justified, but it's supposed to take up 20 characters. In programming, if you were sending this over to another Python program or to anything else, then sometimes having a fixed width is a good way to go. If delimited doesn't work well, then fixed width is what we may need. I don't think I can probably create one, but we'll try. Okay, so if I create that, it's a Spring HTML test.txt. This is fixed width. Let's see if I remember how to do this. It used to be in Excel, it would come up and prompt you, but we'll see. Um, I was sure I saved that under the spring.html. Oh. Okay. Test.txt is right there. Bring that in. And it comes up in the text import wizard. And you can tell it whether it's limited, like you got commas between them, or if it's fixed width. Now, if I choose fixed width, then says this screen lets you set field widths, column breaks, lines of the arrows in signify column break. And I can come there, and assuming I did it right, then we have our breaks there. So fixed width is a common way to exchange data also. You can see that Excel has a wizard in it for handling that. And then this one, I can tell it's a number, I think. General converts numerical values and all remaining values text. Okay. General's what we want. And then that brings in correct. And hopefully those brought in as numbers. We'll see. Like that. So if you're trying to exchange data, somebody says, hey, put in Excel for me. CSV is the best, but fixed width can be something to handle too. Fixed width is sometimes quite useful because it does not matter what garbage is in the middle. Fixed width just indicates starts here, ends here, starts here, ends here, starts here, ends here. If you got CSV, well, if you got CSV as part of a number, then it will cause problems because it'll think, okay, that goes over, this goes over the next column, the 222. I can't highlight that. There you go. 222.99 goes over the next column. So fixed width is useful. That's anyway. Long story to say why LJust is used. Lower converts to lowercase. Now, part of strings are they're immutable. Means you can't after you assign them, you can't change them. You can reassign them, but you can't change like part of it. See here we say greeting is equal to hello world, and then they try to change just the first character. Try to change it to a J, and it says did not support this item reassignment. A lot of people don't understand that. And like if we have this here. I set it equal to hello initially, and then I changed it. And people say, well, that's not immutable. You just changed it. No, I didn't. What this did is this statement here assigns memory location and stores hello in there. And then when it hits this, it doesn't reassign it. It creates a memory space for a variable called greeting. So it's like a brand new definition. It has nothing to do with the first one. They have the same name, so programming wise, you can actually refer to it. But where it's pointing at in memory potentially is a different location. I suppose it could put it in the same location, but they're two different things. you might put this. And then it works. And you're sitting there, I don't understand. You're changing it right and left. No, we're creating a new variable called greeting and assigning it to a place in memory. That's different than trying to change a single letter within the existing definition. So the existing greeting. And so we get that. Now you can access greeting 0, but you can't change it. Okay, so when you're talking about some of these functions like lower or right justify or less justify, okay. Okay, so you see that. I can say x is equal to x dot lower. Not only left justifies it, but lowers it. So you can do a combination of these. And let me see. Dot. Let's see if I get syntax right. You can combine them together. Some books refer to this as a composition of functions. Composition means you put one inside of another. Well, that's not quite what we did here. We didn't put one inside the other, but we chain them together. So it hits a string, and then it first left justifies it, then lowers it, then uppercases it. Not that that'd make any sense. What else is there? I guess that's probably about all I see. Okay, so you can see how you can string those together. Again, function composition. Now, L strip returns a left, and there's a R strip down here. Left and right refer to the trim version of the string. That gets rid of the strings, or gets rid of the spaces, sorry. Let's see. There it is. Boy, I'm blind. I was looking for strip. This returns a trim version of the string. That means it gets rid of the spaces at the beginning and at the end. Why is this necessary? Let's see. State equals to Kansas. State 2 is equal to Kansas. If state, I'm thinking this is the 2 equals in Python. State 2, then that's weird. It didn't go over. Could be it's not equals equals. My language start running together. That's nice. Just too slow or. Okay. Or I didn't have it print anything. Okay, so those are the same. If I put a space here and run this, they're not the same. So if you were to print them, they look the same, but that extra space at the end causes strings not to be equal. That causes you problems in programming. Um, so they have those strips. Strip will get rid of the space at the beginning and at the end. Um, L strip, wherever it's at, there it is. We'll get rid of spaces at the beginning, the left side, and R strip will get rid of spaces at the end. Now they don't do anything about spaces in the middle. So like here, to clean up state, I could say state equals to state dot R strip. And now if I run it, you see how it says they're the same. Sometimes you have a user input. Okay, so it's coming down here, and I'm gonna input Kansas, and I put a space. Now it tells me they're the same. If I get rid of this R strip, then I run it, and I put Kansas in, put a space. See how it doesn't tell me they're the same? So users oftentimes will put spaces in, and your program may need to strip those off, especially if you're stored in a database. But definitely if you're doing comparisons, because Kansas with a space is different than Kansas no space. Now, if you had, for example, this is my story. Hope you like it. It's not the same as concatenation, but and then say state is equal state dot strip and print. You notice, of course, it puts since I just did commas between it, there's one space there by default anyway. But the first one has spaces there at the beginning, spaces at the end, and then this gets rid of it. Nothing new. That's what we've just been looking at. But spaces in the middle, like between this and is, it does not get rid of those. So do not think that strip or L strip or R strip do anything with spaces in the middle. They're only just at beginning and end that those apply to. Okay. And most of you heard me talk about using these in the past. But my first database application, I don't think I got Notepad still running, but let me bring it up. our first database application, I allowed them to freeform put state in. Some put Kansas, some put Kansas, some put Kansas this way, Kansas this way, some spelled Kansas out, some did a uppercase K, some did this. I made it a string in my application, but did not put any kind of check on it. So people were entering state in all kinds of different manners. And I know these first two look the same, but they're not. Uppercase K versus lowercase k is different. Same thing here. I had to go back through and do a lot of data cleanup on the data in the database because the reports were coming out with summarizing the sales. I think it was sales, but summarizing the sale per state. Well, it was having 7 or 8 different subcategories for Kansas. And so it took a while to get that cleaned up. So, I'm doing very simple examples here, but realize that these are very powerful to ensure your data is stored correctly. Okay, grab a drink. Some of these not so important, like translation table. I don't even know what that is. Is you want to replace any S characters with P character. So I should return hello Pam. Yeah, interesting. There's other ways of doing that, but let's see. Partition returns tuple where the string is parted into 3 parts. Partition method searches for a specified string, splits string in a tuple containing 3 elements. Tuple is a list. So we're looking for bananas. It puts everything before bananas in the first string of the tuple. Then it puts bananas in a second. Puts bananas in the second one, and then all day, space all day in the last one. Can't say I've ever had to use that. Okay. Replace the string of specified values. Replace this where specified values replace the specified value. This is the more common one to use. This would be if we were to write a program to do it. Where you go through and replace Kansas, the uppercase K, with Kansas lowercase k. And then you see we get a result. Notice what this is returning. This is returning X, and X is what we print. It's a string. It's not, if I, let's see. If I print text, you notice the original text is not changed. That's what we were saying. The strings are immutable. You're not changing to text. You're going through and using this string and replacing all occurrences of this with this, and then assigning it to another string. So you're not actually changing the original string. If you had something coming in and had your data field separated with a pipe symbol, and you wanted to replace it with a comma, then you see it changes it to a CSV format. So different things you can do with it. Let's see. Replace. That's why I say I don't think I've ever used this make trans uh, method, but replace I've used. R find. Search a string for specified value, returns the last position of where it was found. I cannot see it. Eyes are bad. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Remember, strings are zero based, and so it finds the last occurrence, which is at 12th position, starting at 0. Or index. Search a string for a specified value, finds the last position where it's found. R just, write justified, R partition returns a tuple where the string is parted into 3 parts. Okay, now we looked at partitions. Let's see what in the world R partition is. I don't know. Oh, search to find the last occurrence. So it said, take this first part. I could eat bananas all day, comma space. That's my first part, first string, my tuple, my first part. Eat bananas is my second part, of my tuple, and then a space R, my favorite, would be the third. Let's see. R split, R turns right trim version. Let's look at split. When you do not have anything in the split right here, it is based upon white space. Okay, so that's why this separates it into four parts like that. If I had this, okay, and I want to split it based upon this right here. You see how it gets rid of the first part because there's nothing before the beginning parentheses. Um, X1, since it splits it into two pieces. And x1 would be our second piece. The x0 is the first part of the tuple, the list. So like x right here, x is this. That's our list of items. We have our first entry, which is 0 base. So that's our that'd be x0, and then we have our second one, which is x1. Okay. I don't know what the 3 is. It's too early. Area code, I think. Area code is equal to. I don't think I need to convert that to a string. I think I can do a split right off of that. Split based upon that right there. Let's see, it'll return a list, and I want the first entry. There we go. And see how it returns 333. It's my area code list, and then my area code is going to equal to area code 0. Okay, now the rest of the string is going to equal to area code 1. A little bit challenging to get used to the concept. Area code list. Okay, let's try it again. Area code's not defined. What have I done? Oh, area code list. I'm not printing area code anymore, though. I don't know what happened to that. Which means it's not going to return anything. Area code. There we go. Now let's print the rest of it. Print the rest. It should print 444-5555 for the rest. And you see that. So if I want to separate that, this is, I think, one of our projects we did. At least it was in one of the programming classes. So if I want to split this up again, then I'm going to split it up based upon a dash. And so I'll say area code list is equal to the rest dot split based upon a dash. And so then the next number is going to equal to area code list 0. That would be the 444. Second number will be area code list 1, which would be the 5555. So print num1, print num2. Now this is not based upon fixed width or anything. This is based upon separators. It can get kind of messy if you have the same separators. Like if we have a dash here. See, we got a problem here because our format's changed on this. So there's a little bit of a danger on that when using that. If you're trying to use these splits, then it has to be in that right format, or you may get an error like this. There are ways to check it. So don't think you can't use it, but you'd have to check it. Like here, I don't know how to check it, to be honest. I could have probably guessed that. Length. So length and then tuple. Okay. So if I come back here and if I say if length of my x, now length, I think it returned 1 if I just had 1. So if it's greater than 1, then I'd want to do the split. Because if it's greater than 1 means it's got 2 items. You cannot access item at the index of 1 if that doesn't exist. That's what that's telling me. Okay, so went a little bit further now. 1, 2, 3, 4, 5, 6 comes down here. And since just because I don't want to spend a lot of time on this example since time's escaping me. Doesn't like something. Oh, my indentation's wrong. So I like Python or Spider. I don't know. The indentation all looks okay. Did I run it? Yeah, I did. Okay. So let's come up here, change it back. So if those are there and it's in the right format, then it'll try to do this. So there's ways around it. If you're trying to split based upon a beginning parentheses and that beginning parentheses doesn't exist, it'll break your code. But if you check the length of the list that comes back, then you can check to see if there's just one entry or if there's 2 or more. Okay. Oh, and by the way, if you don't know how many you're going to have, so for example, like if you had this, and I'm going to split it based upon a comma. Assuming I can remember the syntax, I'm mixing up with other languages. Thinking Swift. Python for loop. Well, I'll do it in a while loop because I know definitely in the while loop. Okay, so index. Oh, by the way, let's just print what this gives us so we know what we're working with. I think this was your last assignment. Separate based upon a comma, but you don't know what you're working with. And this is just one way to do it. There's lots of ways to do it. And you see we got a list of 4 items. length would be 4. And so I'm going to start my index equals 0. While index is less than the length of my list, then I'm going to print my x index. And a nice infinite loop, David. Okay. Helps if you actually increase index. Okay, there we go. So very easy way to separate these off into separate strings. You could assign this equal to values and so forth. So again, using that split, you could very easily come up with those. Split lines, split the string at line breaks, return a list, starts with, returns true if string starts specified value. Swap case, swaps case, lowercase becomes uppercase, and vice versa. Title converts first character of each word to uppercase. Translate returns a translated string. I have no clue what that does. Oh, okay. Another, you can do a replace. Also, upper zfill fills the string and specified number of 0 values at the beginning. Sometimes they want this in a report. You see, you put zeros here in the beginning. Reason why is if you got that, you can't falsify it by putting numbers in front of it. Used to be that that was worrying back in the check days when you hand wrote it and so forth. Somebody would put a number in front, and so they could make your check that's for a certain amount, make it for more by putting those digits on the front. With the writing out the number, that kind of eliminated some, but there's still cases where you could put something there. Okay, so some accounting wants you to have that. I think that's finally the last method. Okay, so let's go back to the book. Talk about strings immutable. We looked at searching. Looping, string method, spent a lot of time on that. There's also the in operator. A in banana, so searches for one string and another string. String comparison, we spent some time about that, talked about the problems with spaces and so forth. Uppercase letter versus lowercase letter are not the same. Okay. Yes, that's about it. Let me see if there's an interesting project here. Otherwise, I'll make one up. Yeah, there's some read the documentation experiment. What kind of project is that? I'm going to assign. Exercise 8.2. There's a string method called count that is similar to the function in section 8.7. Read documentation of this method and write an invocation that counts the number of A's in banana. So again, use specifically that string method called count. And then the slice, string slice can, okay. Might be pretty challenging. I'll find another one that isn't as challenging as 8.3. Um, Palindromes are kind of interesting, but until you get used to working with them, they're a little bit of a challenge. Palindrome is where um, if I could think of a word, A would be a palindrome, but examples. Civic, perfect. Um, Whether you read it from right to left or left to right, it's still the same. CIVIC, CIVIC. And so to check if something's a palindrome, there's different ways you can do it. But if you loop through your first character, like if that was a text, for example, your 0th should equal to the 4th, like that. And your next one should equal to this. Now, would they always have? Now they wouldn't have an odd length, but if it's an odd length, your middle one doesn't matter. Um, but I suppose if you had like ABBA, ABBA, there we go, that's a one. Then it doesn't matter how you go about it. So those are palindromes. A little bit of too challenging of a project. So I'll do exercise 8.2, and then I'll think of another one to put out there. So we'll go ahead and stop there. Next time we'll get into we skip chapter 9. So that's just showing you a more extensive case study on strings, and we'll actually get into what we've been working with, lists, so, and then dictionaries and tuples, which are kind of all the same. Questions on anything? Well, have a good day, and I'll see you next time.